Making a return trip to the edge of space typically requires enough jet power to thrust the craft through the stratosphere. But aviation specialists have built a glider capable of reaching altitudes of 90,000 feet, 27,430 meters, using nothing but wind, and are set to attempt to become the highest plane in history in June. If it succeeds, it will be the highest that any winged vehicle, powered or otherwise, has gone. Called the Airbus Perlan 2, the glider is the world's first engineless aircraft designed to reach such heights by riding so-called mountain waves. Alan McCarter, the chairman and CEO of Airbus Group, which is sponsoring the craft, told Forbes it will attempt to reach its optimal cruising altitude of 90,000 feet as early as this coming June in Argentina. Airbus says that any insight gained into flight at increasingly higher altitudes also has implications for the future of both subsonic and supersonic or hypersonic aviation, where given the right technology, higher operating altitudes could provide a range of potential advantages. Airbus recently filed a patent for hypersonic passenger craft that will go to suborbital space and back down again, said McCarter. It's in that region of suborbital space that Perlan 2 will be flying. The goal of the project is to open up a world of new discoveries related to high-altitude flight, climate change, and space exploration, explained the firm. The Perlan 2 is a pressurized sailplane designed to ride air currents that, in certain mountainous regions near the North and South Poles, can reach into the stratosphere. Despite having no engine, the glider's true flight speed at that altitude will be more than 400 miles per hour, 643 kilometers per hour, and the air density will be less than 2% of what it is at sea level. The crew will breathe pure oxygen provided by a rebreather system, similar to what astronauts use in space. In addition to its two-person crew, the aircraft carries scientific instruments to provide new insight into climate change and the upper atmosphere. Because it lacks an engine, Perlan 2 can explore the edge of space without polluting the atmosphere it will study. Glider pilots have surfed on so-called mountain waves since 1932. The process is similar to surfing on a wave in the ocean, except the glider is in the wave rather than on the surface of the wave. Mountain waves form when winds of at least 15 knots cross over a mountain range perpendicularly and the atmosphere is stable. Waves will form on the lee side of the mountains. A glider uses the upward moving part of this wave system to climb. But the maximum altitude of a mountain is typically at the boundary between the troposphere and the stratosphere, and this is because the cold air of the mountain wave encounters warmer air at the boundary and can't rise further. Einar Enevoldsen, a NASA test pilot and founder of the project, saw evidence that in regions closer to the poles in winter, the waves could extend above the troposphere and well into the stratosphere. Previously, no one had searched for waves in the stratosphere in subpolar regions in winter. From 1992 until 1998, he gathered more evidence that these waves existed, and found they might be strong enough to lift a sailplane to high altitudes. Then, in 1998, Dr. Elizabeth Austin joined Mr. Enevoldsen in the search for an understanding of stratospheric mountain waves. She found that the polar vortex, and one of its principal components, the stratospheric polar night jet that only exists in winter, provided the high-speed wind in the stratosphere that powered incredibly high waves. Winds in the polar vortex can reach speeds of 260 knots and upwards, allowing the mountain waves to propagate upwards into the stratosphere. The Perlan project was formed to explore these waves and soar them to the edge of space. In August 2006, Steve Fawcett and Einar Enevoldsen soared the Perlan 1 glider to 50,722 feet, 15,460 meters, using these stratospheric mountain waves. Airbus Perlan Mission 2 is an historic endeavor in the truest spirit of aviation's earliest pioneers, said Tom Enders, Chief Executive Officer of Airbus Group, which sponsors the project. The knowledge gained from this project will impact how the world understands and addresses climate change. But it will also help Airbus continue to innovate ways to fly higher, faster and cleaner, on Earth and possibly beyond. This week's maiden flight was piloted by Jim Payne and Morgan Sandercock. The next step is to take the glider to various altitudes over a series of tests before the pair attempt to reach the edge of space in Argentina in 2016. These flights are expected to exceed even the altitudes achieved by the U-2 and the state Route 71. The craft took to the skies for the first time last year. The flight, which took place over Roberts Field, the Redmond Municipal Airport in Oregon, was the first test flight of the craft, which next year will attempt to set a new world altitude record for any airplane.